Hey everybody, we've been doing some 3D design in CAD software, Tinkercad, and you've seen the printer running in the lab some. I've recently relocated it to the Rankin County lab, and I've got it running right here next to me, making your keychains. So the work you've done in Tinkercad, I've been pleased. Most of you are doing a good job with that. I want you to know a little bit more though than just how to do it. Normally we focus on how to do things, how to do a good job at things, how to make things. I want to make sure that you're getting some words, some vocabulary to go along with this, just so that when you hear people talking about 3D printing, you'll know the words that they're saying, you'll be able to contribute something to it. But the main thing I want here, I want you to understand why it's important. Why is this a big deal? So let me show you.
Let me set the stage here a little bit. This chart is informative if you take a minute to understand it. And what we're showing here is over a period of centuries. All right, this is a long time, hundreds of years, almost a millennium. It's showing GDP per person in England. All right, so let's talk about a few things. GDP stands for gross domestic product. I know you're bored already. Let me just tell you that that means basically everything that is produced. All the food that's grown, all the products that are made, everything that's transported, all the education, all the health care, everything that anybody does that is valuable, that is GDP. Per capita, that means per person. Now we're talking about in England, and the reason that we're looking at England is because it has a long history. If we wanted to look at it in America, we could only go back a couple of hundred years. And so for that reason, we're going to look at England here. Adjusted for inflation and all that stuff, that's economics. Certainly you should learn about that, but for our purposes, just know that these figures are true. So you can see that we're pretty much flat throughout human history. And if this line goes backwards, if it went back beyond 1270, you would see that it looks just the same. Human production has been almost flat for millennia until you can see we start to pick up in here somewhere in the mid 1700s. We begin to improve a little bit. We get toward the end of the 1700s and we're making some nice gains, and then we take off like a rocket ship. Why are humans able to produce so much more now than used to, than at all the other times in human history? What changed? We've had really 4 big revolutions. And I'm going to talk briefly about those. I'm not going to wear you out. It's not a history class, but you need to understand recent history in order to understand where we are and where we're about to be. Okay, so we had 4 big revolutions. You may have learned about the Industrial Revolution. That happened right up in here. It kind of got us off the ground. Before the Industrial Revolution, everybody was pretty much like a peasant or a serf, just trying to eke out some meager existence beneath the royalty who claimed to be divinely chosen to be wealthy and in charge. And along in here in the 1700s, some people began to say, you know what, that's really not right. That's not what Scripture tells us. That's not what we observe. We don't really think there's anything special about these monarchs, these kings and queens. And we think that individual freedom may be a better route. So that's happening right here in the mid 1700s. It's happening in North America, in a country that eventually will be called the United States of America. And it was also happening in France and in other parts of Europe. So people began to get more freedom minded. Okay? That enabled the Industrial Revolution. Shortly after that, we had the electrical, the computing revolutions, and where we are today. But the Industrial Revolution, you've probably learned about this in history class. Some really smart people began to figure out how to use gears and pulleys and whatnot to make machines to automate some of their work. They invented steam engines and cotton gins and sewing machines, etc. We began to have trains traveling all the way across the continent. And as I said, this was kind of in the late 1700s, after some really smart thinkers had begun to try to switch humanity from a monarch mode, a royalty mode, into a freedom mode. And that enabled some really smart people to develop better ways of doing things, like steam engines and sewing machines and cotton gins, etc. So what happened was, a lot of people who used to spend all day every day working in the fields, or sewing, or picking food, or tending cattle, or watching sheep, or whatever, they were gradually replaced by machines. And so we began to have machines who could do some of these things that humans used to have to do. After the Industrial Revolution, then, the hits just keep on coming. We figure out how to make and transport electricity. And so we started pumping electricity down wires all over the place. And we've got lights at night now. Instead of it getting dark when the sun goes down, we just turn on the lights. And that allowed us to begin having factories and other kinds of mass production. You had some more really smart people figure out things like the assembly line and other efficiency improvements. And this is all going on in the late 1800s and early 1900s. You'll hear all about Henry Ford in your history class. And more and more labor is being replaced by machinery during this time. More and more things that people are just following instructions, that was going away about this time. Machines are starting to do more of it. After that, we started figuring out how to get machines to do our figuring for us. So before, we had machines hauling things around, like trains, or picking cotton, or weaving clothes, plowing fields and things. Well, some more smart people began to think, hey, what if we had machines do our computation for us? What if they were doing our adding and accounting and whatnot? And so they began to invent computers and gradually make them better and better. And of course, as you know, in your lifetime, they've just continued to get better at an exponential rate. We began inventing robots to do the labor in the factories. So the factories were brand new earlier in the century, and now we're staffing them with robots. Instead of people manning the assembly lines, you got robots manning the assembly lines. Labor continues to get automated away, but now you're beginning to see things like secretarial work and accounting work, human resources, those kinds of things. Machines are making that a lot more efficient, and therefore requiring a lot fewer people. And so a lot of office work is kind of under pressure, and machines are kind of impinging on those roles. So it started really in the 60s and 70s. Computers were invented before then, but really the microprocessor enabled it to take off like a rocket. And so that's going on in the 60s and 70s. And then in my own lifetime, we've seen the internet created and take off. And so now, not only are computers doing a lot of our work for us, they're talking to each other and working together. And we're beginning to see artificial intelligence do more and more. Everywhere you look, everything is a computer now. In the software business, we have an expression. We say software is eating the world. But if you look around you, if you look in your kitchen, you'll see that many, maybe most of your appliances are computerized. When I was a kid, that wasn't a thing. A toaster was just a heating element with a handle on it. But now everything is smart. And this is going to continue. You're going to continue to see labor and office work becoming automated. Now, what's that got to do with 3D printing? You've all seen the 3D printer in the lab. You've seen it going. It's cool to watch. It's cool what we are able to make on it. But I want you to understand it's a transformative technology, and we're at the beginning of it. And gradually over your lifetimes, you're going to see fewer and fewer, oh, hey, let me go to the store and get that. Or even let me order one and have it arrive at home. More and more, as 3D printing becomes commonplace, you're going to see more and more, let me make my own, exactly customized the way that I want it. So the keychain project that you've been working on is just an example. I had you put your names on them on purpose so that it would be uniquely and specifically yours. This is going to become more and more normal for more and more things in your homes. It is a transformative technology. It is a fundamental pillar of this fourth revolution, 3D printing. Now, so that's the stage. These are some things that I want you to learn. These are some terminology. And as you go about your business day to day, you'll hear these terms more and more as time goes on, and you will know what they mean, and you will be smart for it. Manufacturing is one kind of making. This really means mass producing something. Normally it happens in a factory. So some engineers somewhere designed some product that a lot of people want. Whatever it is, maybe it's shoes, maybe it's a toaster, maybe it's Lego, maybe it's a chair. Whatever it is, some engineers got together and fixed it just the way that people like it, and then they shipped off the specification to a factory and said, okay, make a bunch of these. That factory making a bunch of them, that is manufacturing. Now, 3D printing, there's a fancy word for it called additive manufacturing. Additive manufacturing. And what that means is the product that we're making, we're going to make it a layer at a time by adding a little bit of material. So you've seen the way that our printer works. It moves around, spitting out a little bit of that melted plastic. It is adding material, is adding that melted plastic onto the thing that we're making. That is additive manufacturing. Filament is that stream that the 3D printer melts and spits out. You've seen I've got different colors of it, but that's all it is. It looks like weed eater string. That's called filament. CAD, you guys have been using CAD software. It's the kind of software that engineers use to design things and draw things. You've been using Tinkercad, which is a great browser-based, computer-aided design software, and you've all been doing a pretty good job with that. The last thing is Slicer. That is special software that converts the 3D object that you've drawn, for example, in Tinkercad, when you drew your keychain, the last thing we do is we use a slicer to prepare that for printing on our 3D printer. And I've got a video where I'm going to show you that happen. So like I said, you've used CAD software. This is it. You've all been making your keychains in there. A slicer. This is the slicer software that I use to get it ready for to go on our 3D printer. This is a picture of our favorite toy in the lab, our 3D printer. Notice right here, this is the filament. Okay? That's the string that we're going to melt and spit out. Now look, I want you to learn the terms on this slide right here. Don't be surprised if we see that show up in some kind of an assessment. Okay, 5 terms there. I want you to know them. All right, thanks everybody.